Hi, I'm Gayatri Gogineni. Today we'll be talking about different train control systems. The agenda for today is covering PTC, ERTMS, and some mainline signaling solutions. So we'll talk about PTC now. So what is PTC? PTC is a positive train control system. It is an integrated command control and communications information system, uh, which helps to give a warning to the engineers if there is going to be a collision or a hazardous movement that the train is going to make further. So this system helps to give the engineers a warning and helps to predict the collision and the hazardous movement that might occur. Let's see the need for PTC technology. Most of the rail lines, they are relied on human resources, either the operations or the safety regulations that the rail line should follow. Because of the absence of any safety regulated enforcement system that is not in place, that led to many human errors and that prone to accidents that occurred. So the National Transport Safety Board requested FRA to do a feasibility study on automatic train control system. And then the PTC timeline has been developed. So let's see the overall timeline of PTC development. So in 1994, the PTC term itself has been introduced to FRA, means like in a report to the Congress. So that is in 1994. And in 1996, the FRA Railroad Safety Advisory Committee created a working group to derive all the safety objectives that need to be considered. That happened in 1996. So in 1999, the implementation of positive train control systems, RSAC, which is Railway Safety Advisory Committee, they published a report how the government and the railroad industry would facilitate PTC development. That happened in 1999. They derived a report which gives all the details of PTC development. So then in 2004, FRA initiated a study which determines the cost and the safety benefits of PTC, and the estimation will exceed around 2.3 billion to implement this system over 100,000 miles on track. So all the details of this data has been published in the link provided here, which I'll be sharing it with you as well, so that everything that has been provided in this document is publicly available, so that you'll have an idea. So this is the amount which they published, and that is in 2004, as I could see. So now let's move on. After 2004, in 2005, FRA publishes a final rule on the functional requirements, what needs to be required for achieving PTC. Whatever the system could be, PTC technology would be neutral to the system. So that is what they derived in 2005. So the PTC technology is going to be neutral for any system it is going to be implemented on. So that is what they derived in 2005. So then in 2008, in response to several fatal rail accidents that occurred between 2002 and 2008, Railway Safety Improvement Act, which is RSIA, was signed into law. And then in 2010, the final rule for PTC implementation is issued by FRA, and it requires the implementation of interoperability. We'll look into interoperability later. For most of the freight and rail passenger rail carriers, by December 31st, 2015, the implementation of PTC needs to be done, and it should be interoperable. Due to technical and legal complexities with PTC implementation, Congress passed HR 38119, Surface Transportation Extension Act of 2015. Under this law, the railroads got an extension like December 31st, 2018 to implement the whole PTC. Before it was 2015, and now they extended it up to 2018. And so 2018 is the implementation deadline, as you could see. So now let's see what Rail Safety Improvement Act is. PTC, it refers to communication-based or processor-based train control technology, which needs to prevent all these, which is train-to-train collision or over-speed derailments or any kind of work zone limits if there are any incursions to the established work zone limits. And if the switch is in the opposite position, the movement of the train need to be stopped. It should basically the PTC itself needs to prevent train-to-train collisions, speed derailments, and then the incursions if there is a work zone area, and it should prevent the movement of the train if the switch is in a wrong side. So PTC needs to prevent all these. That's the Rail Safety Improvement Act rule says. So what PTC prevents? Again, we are deriving the same thing. What does PTC do? It helps to prevent all the 4 listed items, which are train-to-train collisions, over-speed derailment, and work zone areas. If there incursions are in any work zone area need to be prevented, and movement of the train if the switch is in the wrong position. This is directly available in the PTC system information in the railroads government site. So as you could see, this is the overview of PTC system information where it describes. So this is what the PTC system should prevent. So let's go back. So all the data provided is in the public domain. So what are the PTC systems that are approved and what are in use? CBTC, which is communication-based train control, everybody knows about it. And ETMS, electronic train management system. I-ETMS, interoperable electronic train movement system, WAPTEC, which is developed by WAPTEC. And ITCS, it is incremental train control system. Interoperable incremental train control system, which is developed by Alstom IITCS. Advanced speed enforcement system, which is a combined product of Alstom and Ansaldo. Enhanced automatic train control, Alstom ZEATC, which is enhanced automatic train control. Let's see all the displayed information right here. So it's in the same types of PTC systems in USA. As you could see, ASCS, CBTC, ETMS, I-ETMS, ITCS, EATC, I-ITCS, and SafeNet. So how does PTC work? So let's see how PTC works now.
Positive Train Control, or PTC, is changing the way railroads operate. Today, Union Pacific engineers and conductors have 5 sources of information: personal knowledge of the territory they regularly work in, basic rules such as speed limits found in a timetable, additional printed directions called track bulletins, wayside signals or lights that indicate whether it's safe to proceed, and voice communication from a dispatcher who may be providing additional instructions. PTC integrates these 5 sources of information into one single computer-based system. The PTC locomotive computer communicates with various wayside devices and Union Pacific's Harriman Dispatching Center, connected by more than 800 radio towers installed throughout Union Pacific's network. The geographical characteristics of the railroad, information found in a timetable, track bulletins, and most dispatching communications will now be loaded into a database. Things like the physical layout of tracks and current speed limits update in real time on the engineer's PTC display. If the engineer does not react to instructions in a timely manner, PTC fully engages the locomotive's brakes, stopping the train before an accident can occur. PTC reduces the possibility for human error-caused incidents, creating an extra layer of safety for Union Pacific railroaders and the communities we serve.
So that is how PTC works, and let's see what is interoperability and PTC principles of interoperability. Interoperability is nothing but how well one system is communicating with the other one. So if the system is the host railroad has one system and the tenant railroad has one system. How does they both talk to each other? So how does the locomotive able to control the host railroad and the tenant railroad? How well they communicate with each other, and how does the PTC system response, including any kind of uninterrupted movements? Because of these two different systems, there shouldn't be any effect on the movement or any kind of effect at the boundary. So that is how interoperability plays a major role here. So let's see the interoperability. What does interoperability says? So it is the ability to control locomotives of the host railroad and the tenant railroad to communicate with and respond to the PTC systems, including uninterrupted movements over property boundaries. So that is what interoperability is. How can we achieve this is by providing data using ITC protocols between back office server, communication-based systems, and the wayside equipment. So how well the ITC messages are being transmitted between different um, different zones. So that is where the constant communication, it helps a lot. There should be a great communication between the host railroad and the tenant railroad, and it should be done as a host railroad as well as a tenant railroad on other properties. Means like it the communication must be flexible for both host railroad and the tenant railroad, both of them, when they are in when the locomotive is on their property. So let's see what is interoperable electronic train management system is. I-ETMS integrates new technology with existing train control and operating systems, which helps to enhance the train operation and safety. And it reduces the potential train accidents, and it helps to prevent uh, track authority violations, speed limit violations, unauthorized entry into work zones, and then the train movement when the switch is in the wrong position. All these can be prevented, and crew remains in control of the train with I-ETMS. Its system monitors and ensures crew's compliance with all operating instructions. Any operating instructions, the system monitors if the crew is in compliance or not. So the I-ETMS, it has a display screen where it provides the train crew a great information that the train crew requires. I-ETMS helps with to stay the crew to be in compliance through display screen. Means like all the information can be displayed in there. So what are the functions of I-ETMS? So as the train moves down the track, I-ETMS through the geographical database, the global positioning system of the train can be achieved, and the warning and the braking curves according to the speed limits, and then the train and track information, location, movement authority, speed restrictions, and the work zones, and any kind of restrictions, all can be achieved on the onboard computer. So everything can be displayed. So I-ETMS, it also communicates with wayside devices, checking for broken rail or any kind of switch alignment, if it is proper or not, and any kind of signal aspects that are changed. So everything can be communicated well via I-ETMS. And it is a real-time analyzed data that could be provided, which improves train protection through safety net. So this is a Waptec system. You can go and view for more details if you are interested. So this is I-ETMS we talked about. And let's see the positive train control system in asset management portfolio of Waptec. So that's Baptec's positive train control asset management portfolio. So let's see the PTC system segments now. All the components are integrated into a single system, which is divided into four segments that are office segment, wayside segment, communication segment, and onboard segment. So the PTC technical overview contains of office segment, just like we discussed, wayside segment, onboard segment, and then the communication segment. As you could see, computer-aided dispatch communicates with the back office server, which is in line with the communication segment through radio provides communication link between office and the equipment, and the data link radio uh, is in uh, contact with both the trackside and the back office server, which inline transmits the data and the track's status and the signal aspect and the switch position, which are in the wayside segment, through communication segment to the back office server. This is how everything is interconnected, and the GPS location information which would be provided to the onboard segment will also be transmitted to the communication segment, which is again interlinked to the BOS. The onboard equipment would be segment would be continuously communicating with all of this data. This is how the whole technical overview of PTC looks like. So office segment, it includes back office server, which stores, processes, and all the information received from computer aided dispatch system, onboard equipment, and the wayside messaging server. So this is how the communications would be saved in the back office server, and the communication would be done via that. And all the information on the trains, tracks, work zones, and the speed restrictions, everything would be maintained. Back office server issues authorities, movement authorities, and the notifications to onboard segment. So the information would be given from back office server would be directly communicated to the onboard segment through the all the respective interfaces. The onboard segment sends status and reports information to the back office server. Both of them would be in line. So that is how office segment works. And office segment is interoperable train communication message server. It resides in the back office. It contains a server which is interoperable and is in the back office. Whatever system or the train which is on the property needs to be well communicated with the existing system, and it should be interoperable. So this ITCM, which is a messaging server, train communication messaging server, it ensures that all the trains understand them, and it is produced by Meteor which is owned by BNSF, UP, NS, and CSX communication system for all the trains so that they could understand them. The class 1 freights invested to ensure that they are interoperable with each other. It is a product owned by Meteorcom. Now we are talking about wayside segment. Wayside signal system is the underlying safety baseline for PTC overlay. It reports the switching position, signal indications, and the status of the monitored devices. Everything would be reported and is transmitted to the onboard and back office segments. So, and the train communication would be through 220 megahertz radio and is the primary path for wayside to train communications. PTC 220 megahertz is the radio communication system that they'll be using. It could be, the communication could be peer-to-peer or wayside to train, radio to radio. Peer-to-peer is nothing but wayside to train or radio to radio. It could communicate in either way, and the communication would be relayed to the back office and is transmitted through a base station via wayside status relay service. That is how they communicate. So communications, as we discussed before, it is 220 megahertz network communications, and it is composed of how they'll be communicating is through ITC messaging system or ITCSM, which is ITC systems management. So 220 megahertz radio is designed for this specific application, and it consists of ITC messaging system. The main components of ITC messaging pathway are back office and application gateway, ITC messaging application gateway, and ITCSM gateway assets such as 220 megahertz ITC radio. So 220 megahertz, again, it is produced by Meteorcom, which is owned by Class 1 radio specific for PTC. So let's see the details of Meteorcom here. I do have the link where. So this is how interoperable train control messaging. Interoperable train control systems management. So this is how all the assets will be configuration of assets from back office. This is how all the data would be transmitted to the back office. So let's move on. So the communication segment between the back office, onboard, and wayside totally relies on a bidirectional and a redundant communications network. Obviously, it should be bidirectional and is resilient. PTC projects include 5 components: base station radios, onboard radios, wayside radios, backhaul network, network management system. Okay, all the data is provided here. You could go through the link if you are interested. So let's move on. So onboard segment, it receives the movement authorities information through back office server and it notifies the engineer or the person on board. And the information would be taken into action as soon as they can. And as soon as the appropriate person has got the information, the onboard computer will automatically apply the brakes if required. If at all, if the onboard system loses any kind of connectivity, then obviously the information which needs to be reached to the onboard driver would not be received. So the train would stop automatically before entering the next block. That is how it works in the onboard segment. These operating rules are developed to ensure the safety movement of the train, which is interoperable again. So this is the architecture. So this is submitted to the government congress.gov if you see. So this is how it looks. And as you could see, ETMS wireless network, it is communicating between the locomotive and the wayside, and the nearby base stations and the wayside equipment is communicating with the network operating center, which is nearby. This is how the whole architecture is. PTC implementation could be of 3 types: vital standalone, vital overlay, or non-vital overlay. So as a vital standalone, PTC, what it does is it replaces all the conventional existing systems and integrates with all the train control functions and gets everything into one system. Currently, PTC projects will follow either non-vital or vital overlay. It has no standalone PTC system as of now, PTC technology as of now. So it could be a vital and non-vital, and then it in all the CTC existing system, it integrates and it gets to one system. So suppose if it is a vital overlay, PTC implementation, trains are governed by PTC while the block and interlocking functions are provided by conventional CTC. So conventional CTC method would be given, and trains are governed by PTC while the block system and the interlocking functions would be a conventional CTC method again. When PTC is used as a non-vital overlay, trains are still governed by conventional systems, signal indications, and or verbal authorities. PTC just acts as a safety overlay in the background. It is just a safety. It is kind of an indication system if it is a non-vital overlay. So that is the implementation part of PTC. Now we'll go into ERTMS. So we'll see what ERTMS is. ERTMS is European Railway Traffic Management System. It is a control, command, signaling, and communication system, and is a software-based system for railway management and safety control. It is adopted in as everybody knows that it is an European system, and it is a standard interoperable system that is in use. It is a combination of PTCS and GSMR. What is GSMR? GSMR is nothing but global system for mobile communications. We'll go into detail now. ERTMS and its components. So ERTMS, it is a combination of ETCS and GSMR. ETCS is a European Train Control System. It is a automatic train protection system that continuously ensures the train, whether it is in line with the safe speed and distance, and it provides relevant information to the other relevant authority that needs this information to be transmitted to, like the driver on board, to the onboard equipment. So it is an automatic train protection system to replace, it is going to replace the national ATP systems. So GSMR is a mobile communication system which has a specific frequency that helps for voice and radio communication between the track and the train. Based on the standard GSM, obviously, they are using different, specific frequencies reserved for rail applications. So what are the levels of ERTMS? ERTMS level 1, 2, 3. So let's see what level 1 is. It is going to have Euro bellies without infill and then an overlay to the existing signaling system and the movement authorities through Eurobellies. The communication to the movement authorities would be through Eurobellies, train integrity and position by track circuit. So that is how the communication would be. The communication would be through the track circuit while coming to the train integrity and position, but the movement authority would be getting the information through the Eurobellies, and the overlay to the it is an overlay to the existing signaling system. Suppose if it is Eurobellies plus infill, Euro loop radio or extra bellies, then the overlay to existing signaling system again, and movement authorities through Eurobellies, train integrity and position by track circuit. So that would be through Euro loop radio or extra bellies. That is how it has two sections. It could be via that, and or it could be via infill. So what is ERTMS level 2? Eurobellies plus Euro radio, GSMR, which is GSMR, and radio block center. No more track signals required. So the data would be already received, like as he says, then for my authority and track description came completely over the radio. Therefore, my cab display is always up to date and I need no line side signals. So it doesn't require any no more track side signals required. That is what the second point describes. Movement authorities through GSMR and train position via Eurobellies. Train position would be derived through Eurobellies, and movement authorities communication would be through GSMR. That is how level 2 works. And level 3, Eurobellies plus Euro radio GSMR plus radio block center. Movement authorities through GSMR, authorities through Eurobellies. Train position via Eurobellies again. So this is how train-borne equipment would get the information through bellies, and train integrity on board would be, and it would be a moving block. So let's see the signaling levels again in detail. Level 1, this level 1, what does it say? So the application works with the existing signaling equipment. Obviously, this existing signaling equipment, whatever it is going to work with that. And the information would be transmitted through beacons which are between the rails, and the onboard computer uses this information, which derives the train location and appropriate speed profile would be derived according to that. The information on maximum allowable speed and the braking distance is displayed on the train operating system. The train onboard equipment would be displaying that. It automatically applies the brake if the maximum speed is exceeded under the moving authority. So this is how level 1 works. If at all, if we are going to level 2, then the features would be continuous communication between the train and the control center using the GSMR, the global communication system, radio communication system. And the train transmits its location obviously through the beacons to the control center and receives movement authority and signaling information in return. So there would be a two-way communication. Level 2 configuration eliminates the need for wayside signals, as we discussed before. Just like before, what we discussed here, that we don't need any kind of information from so he doesn't require any information. My all the onboard equipment has got its information. So the data is up to date, so I don't need any line side signals. That is what the driver says. That is what level 2 configuration. It doesn't require any wayside signal and signaling information. What are the benefits of ERTMS? It gives us a great interoperability and cross-border operations, and helps to supervise every train according to the optimum characteristics. High line speed and shorter headways between high-speed trains. Increased line capacity, greater safety and efficiency for passengers, improved revenue, and a great potential for operators, lower maintenance and life cycle costs. So the maintenance would be very low, and the cost would be very less. Let's see some mainline solutions. Interflow is a product which provides, and it is a product of Bombardier. So Interflow has around 6 products, I think. Yeah. So Interflow 250, 450, and 550 are of ERTMS mainline solutions, 1, 2, 3 levels, and are used for secondary and regional lines and high speed and commuter lines. Interflow 150 solution, and it is dedicated for industrial and mining lines. So for depots and stabling yards, Interflow 100 is suitable for depots and stabling yards, and for if at all, if the network for busy networks, they are going for Interflow 200. Conventional rail control solution for main lines for busy networks where headways are reduced, and it is still for highest safety integrity level is required. So if we consider 550, Interflow 550, it is going to be a GPRS LTE Tetra level 3. So they are going to use a private mobile network, I think, if it is 550. So yeah, so these are the ERTMS. Since we are talking about ERTMS, I just wanted to show some mainline solutions. So these are the 250, 450, 550 that are that we are using for high speed and commuter lines and regional lines, secondary and regional lines, and 200 is for busy networks. Headways could be reduced, and for stabling yards is for 100, and 150 is for radio based solution for mining lines, I think. Yeah, industrial and mining lines. Cost effective depots and stabling yards, it is 100. So this is for 100. Last one is for 100. So yeah, so thank you so much. I had a great time explaining PTC and ERTMS with you. I'll be back soon with CBTC and interlocking soon. Hope you had a great time. Thank you so much.